Thank you for being with me again. We are looking at applications of if functions. How do we use if functions to solve ordinary life problems? Uh, we shall look at case studies. We shall throw cases as displayed in the shots. Then those I share my contacts out. Feel free to take them. You can pause the video to take these contacts. Please subscribe the channel so that keeps up. These are my names: Bossa Eric Ronald, your tutor for ICT. Um, I have quizzes in the comment section. Tap the link to access quizzes after going through the videos. Test your learning area. So this activates an online quiz, and you run, you assess right away. So we looked at if functions earlier. We have a simple if function carrying one condition. And then we saw your cases where you have to have multiple conditions in some situations where what you are dealing with has more than one condition. We are going to look at cases like that. Then we shall finally look at if functions that work with other functions. We shall see still some cases. Then we go on to grading. So we take an example of class records, learners, against their scores, the percentage record, and we're having a pass mark of 50. 50 plus is a pass, and those below 50 is a fail. So we shall use, as it were, the if function to test the condition. So the test value must be greater or equal to 50. We have to put the equal so that the 50 is included in the passing tire, because those who pass must have 50 and above. So 50 to be included in the tire of pass must be having equal. So those that are greater, even those that are equal to 50, 50 and above is a pass. So what we do here, we have the logical test. The logical test is as shown, but then we have a value if true. So we specify the application what the computer should return. Else, if you don't specify, it returns you true. For those that meet the condition, those values that are above or greater than 50, it is true to the condition. Else, it is false to the condition. Those that are below 50, it is false. But here, we want the application, we customize the result, what it returns to us, and place it in quotes. The practice in programming, you place what you want the computer to return in quotes, double quotes. So we have cases for true, the true value is pass. But then we have those that don't meet the condition, we set the result to be fail. So, and then we close off the parentheses, and there we have a function that computes, that returns logically the values therein. The values under test are checked if they are above or equal to 50. So when we run the system, it does the needful. So the value that is 50, it is under the tire of pass. If you run the function without this equal to 50, it means it only considers those that are above 50. 50 will not be in the passing tire. So when you run this, it will show you that 50 is a fail. But we want it to have 50 included in the passing tire. Then we include the equal sign so that 50 is categorized under the passing. So then we run the function and does the needful, so as it were. But then we need to look at a case where some results are missing. For example, if someone never sat the exam. So here, the computer will fail the person who never sat the exam. But fail is for those who attended the exam, those who attempted. Failure is a grade. So what do we do here? We need to modify the if function to have another condition in it represented. So we have one condition, but then we need another condition. That's when we talk of a nested if function. An if function that runs more than one condition. We need to look at the condition of values that are empty, where there is no mark. So in that case, we express it this way. We use another if function placed between the original if function, the condition. We place it between the previous condition, because we have been having two conditions. The condition of pass and fail, the result rather, pass and fail, and one condition. So there's one logical test, or what I'm calling a condition. But then when you have another logical test, a test to see if the address is blank, besides being it greater or equal to 50, it will also test if the address, the value is blank. So how do we express the blank value? So in this case, we are testing the test value is checked if it is blank, and to represent blank, we use two double quotes following one another. So the double quotes are representing a null value or blank. So here we call it null value. Then the result correspondingly must be null. You also put the double quotes, separate that condition from the rest, from the following one with a comma, as for the others. So let me move this. So we have this as the second logical condition, having a blank address, where cases where it's a blank value, cases where it's above or equal to 50, and others fail. So we have opened the parentheses 2 times. So we have to close it correspondingly twice, because parentheses happen in a pair. Brackets happen in a pair, and they have to be closed correspondingly twice to have a complete expression. So when it is done, it appears like seen greater or equal to 50 is passed. If it is blank, because you have to open the parentheses after the if, for every function, there must be, the arguments are enclosed in parentheses. So here it's another function within the function. So this makes us what we call the next nested if function, having two conditions. And the third one represented by fail. Here we don't have to add the if representing fail, just a repetition. So here we have if it is greater or equal to 50 pass. If it's blank, then return blank. And if it is below 49, below 50, it is a fail. So this is the third case. Then the formula does the needful as illustrated. Where it is blank, it does the needful. So that's the nested if function. Let's look now at a payroll. We're having employee names on in this column where their wages are appended. And then we are seeing a case where we are having those above $200 having a 20% tax. So if a wage is above $200, it attracts a 20% tax. Then you have to compute the tax in one of the addresses here. So right away, as it were, we use the if function to do the computation, the necessary computation. So if the test value is greater or equal to 200, a 20% tax is attracted on that salary as shown. So this is how we express the result. So in the other cases we've seen, we have been having a result, either a text string or a null value. So the result here is a text or null value. But in this case now we are looking at something where the result is a calculation. So the logical test is greater or equal to 200 for the wage, but the value to be returned is a calculation because we are calculating to see the amount of tax. In this case, it is 20% of the wage value. So the value in the address here representing the wage is multiplied by 20%, return the tax. Otherwise, you return nothing, null value. So that is a computation on the wage to see the tax value. So those that meet the logical condition of being greater or equal to 200, the logical test are computed, the tax is computed as 20% of the wage. Otherwise, there's nothing to be represented because there's no taxation. So then the needful is done when you replicate the computation using the formula. So there we are, logical test, calculation, and null value. So we are seeing a case of the result being a string, a null value, or a logical test. Then we go on to see a tax discrimination grade based on tiers. Those that earn above $500 taxed at 18%, $400 at 15%, $300 at 12%, $200 at 10%, while those below $150 have not attract any tax. Then also have to use an if function in that case, but a modified one because this is handling more than one condition. If each tax tier is a condition in this case. So look at the first condition. If the wage is greater or equal to 500, the first case, it attracts a tax of 18%. So here we are calculating the tax that it attracts. That the first case, the tax is 18%. Then we need another if condition and open the parentheses, and the test value must be greater or equal to $400. There we have a taxation of 15%. Then we go on the next tier, greater or equal to 300, taxation of 12%. Then another condition, each tier is a condition, a logical test, or the condition for that matter. Greater or equal to 200, it attracts a tax of 10%. So this is an expression of the calculation. Therein, 10% of the wage is calculated. Then the last category where it is below $150, there is no taxation at all. We express it with a null value, and then we have to close the parentheses corresponding to the number of times we have opened them, because each parenthesis is a pair. We have a pair of parentheses in each case. So for each if condition, there is an opening parenthesis. So by count 1, 2, 3, and 4. So there should be 4 closing parentheses to make up the full function. Then there the function goes with each condition which logical test is represented, starting from the first one, bubble equal greater or equal to 500, greater equal to 400, greater equal to 300, greater equal to 200, and the last one being a null, returning a null value because there is no taxation. So when we do the needful and run it around, we see the computations made therein. What follows is a shopping list. For the third case, we have seen a grading, class grading, we have looked at payroll, but now we want to look at a shopping list, and here is where we are going to look at the modified if function, an if function that works within another. So we have seen the if condition, if function having one condition, a nested if function having more than one condition. Then here we are having an if function that works with another if function. First, we see the on inspection, a little description here is we have items, but then they are categorized. We have different items, books, under scholastic material, pencils, scholastic, wipes, sanitary, donuts, edibles, the bag is scholastic, hanky is wear. So we have a classification of the products. Then we follow with the rate, unit price, followed by the quantity bought and the amount therein. So we now need to do a computation. Count how many scholastic materials by quantity. I mean by category. How many items do we have under scholastic material? So use a count function, but based on a condition. Count function based on a condition. So we have to count if count number of cells within a range that meet a given condition. How many cells here meet the condition? We are starting with scholastic materials. So, and then we open the parentheses, specify the range from where you're getting values, the counting range. So this is the application is counting how many items, how many instances does scholastic appear, how many items are under the category of scholastic material. So then we put the criteria, and it must be in quotes. And close off to give us the result. So this is a count function, but based on a condition, counting if the data in the range is meeting a specified condition. So we can reuse this function across. So when we run it across to reuse it, it has to be modified because we have to cater for sanitary, edibles, and wear. But still, when we inspect, the problem arrives when we copy the formula, the range adjusts, because this is the selected range. In the following cases, the range is noticed to have an adjustment. Starting here from 5 to 23 is the range we are interested in, but here it starts from 6 to 24, meaning it excludes the first value of 5 and then goes to 6. then increments the last value. So when we inspect, the range is tampered with. It includes an additional value, but then excludes the first value, the value in the first range. The first value in the range is excluded, and the last value is an addition. So here the range is showing an erroneous one. Likewise, this one continues, makes it worse, excludes the first two, 5 and 6, and then increments the last one, 23 to 25, like that. Meaning, it adds unnecessary values, unnecessary items. Because when we look at the case of this last one, when we inspect the range, it is excluding all these, as you see where it is demarcated, and then it is including items that are out of range because it runs up to here. So we shall still get a value from the computation, but it is erroneous. What we do in that case to put things right and have a fixed range, as it were, because these values are changing, 5 and 23, we precede them with a dollar symbol. We precede these values with a dollar symbol. This is what we call cell referencing. The concept of cell referencing. So this is a mixed cell reference. You can also have what we call an absolute cell reference, where both the row, in this case the row is not tampered with, it is in row D. Row D, our range is in row D, but values, our range is in column rather. Column D, the column is not affected, but the rows are affected because 5 will change to 6 and 24 will 23 will increment 24, 25, 26. But the column value does not change. So you can have a case where also fix the column value. There are cases where we need to fix both. But in this case, since it is only the numbers changing, we only fix the numbers by preceding them with a dollar symbol, so that the range is fixated and does not change as you copy the formula. So when you copy the formula through, you'll get to see the same value appearing because I have scholastic materials here. But here, as it were, we are considering, we first consider scholastics, then we are going on to sanitary. And then we have to modify this formula and it caters for what we are looking at. So now that we have arrested the issues of the range, we then adjust the item we are looking at, sanitary. So the system is counting how many instances of sanitary are appearing in our range. Then when we confirm, it shows us how many. Likewise, we go on to change the corresponding ones. Here we are looking at edibles. It's good to mind the spellings. The spellings must be exactly as they appear in the range. Because edibles is in plural, you have to include the S. If you make it edible, it will not count it rightly. It will look at another condition. But here it is edibles, because here it is also spelled as edibles. You have to be mindful of the spelling in the range. Then you confirm, it also gives you the needful. Then you go on to where and put the word. Then we have the necessary. So this is a count by category. How many instances does a certain category of items appear? And then the assessment comes as the system shows out there. Then you can go on to amount. can also have amounts calculated. Then we go on to calculate the amount due to each item category. One may be interested on how much they are going to spend on all the scholastics, on all edibles, on all sanitary. Then we need to sum up the amounts due to each category. So we are going to have a formula that fetches data from two sources. It considers the category and then sums the amount. So that function is the SUMIF function. So it looks at a range where it will find the criteria. So the criteria in this case comes from the category. We want to see how many wares, how many edibles, how many sanitary, how many scholastic. And then we sum up each category. So we specify the range, as it were. After specifying the range, then we go on to specify the criteria as based on the category. So we are starting with the scholastic category. Then we're going to sum up all scholastics. Beware of the spellings, the way they appear in the range. They must match exactly, no mistake. Then we go on to locate the sum range. This is the range where the criteria is being drawn. And the sum range is the range where the summation is going to take place. So it's going to sum all amounts due to scholastic in the first instance. Then we have another range appearing. We have the range of the criteria range, then the criteria, and then the sum range. And you close off. So there, the formula appears. The formula shows all scholastic in the range, the category range, the range of category. We are trying to see scholastic materials, and then we are summing up in the amounts range. So that will get the sum. Then you have to reproduce the formula to calculate others, but as it were, it's erroneous, as you may have seen already, because the range is adjusting. Then we go on to adjust the ranges, both ranges. They must be fixed so that they don't increment at the bottom and exclude at the top, as we saw in the first case. So we precede the numbers with dollar symbols. The columns are not affected because they are preserved in this case. Then we have something like that to have a mixed cell reference, so that because one is fixed, and then we replicate. When we replicate, we get a uniform value because we need to adjust the category. So in the second case, we need to work with sanitary. So we modify the category and set it to sanitary. Then that's needful, sums up all sanitary items. Then we have another case of the other cases are edibles. Edibles, that's the needful. Then the where, is also handled accordingly. So the range, the criteria, and the sum range. That is the amount in this case, and this is the category where the criteria is being drawn. And then it does the needful. So that is the categorization, summing by category, using the column of category, but summing in the amounts range. So these are modified functions, but we need to see something further because when we look at this practice of using dollar symbols to make the range fix, there's a simpler way, a simpler approach. So I can choose to name this range instead of using those dollar symbols. Another approach, I select the range, and in the name box I give it a name, say category, as it is called, the title. So I rename it category, okay, and press enter. When I press enter, the name registers. Okay, previous names have been used, but this name registers such that when that range is selected, it appears as category in the name box. So that's the range name. So when you are to use it here, that won't bother you because it's a fixed name. So you will count if as it were. So the range, you'll have to put the name which we gave it, category. Beware of the spelling. And then here we are counting how many, in this case, scholastic materials. Scholastic, how many instances are they appearing? Then it does needful, and then we replicate the formula. So here we go on to modify the rest accordingly, so that we get the necessary results. But this approach is now different because we have used the category name, we have used the range, we have named the range. The range in question has been named, which may simplify matters. So the spelling has to be minded. One has to be mindful of the spellings, otherwise the system may not return any results. So there it happens. How many instances of scholastic materials, sanitary edibles, and where are appearing in our list? Then likewise, you can also go on to sum the amounts, as we have seen sum if. So we have a range. So we can also choose to name these two ranges. So what you do, you name the ranges first. You can choose to name them. This one is already named as category. The system has recorded it. Then this one is amounts. So we can also name it as amounts, as it were in the name box. Press enter, it registers. So in the drop down list, it is appearing amounts. Then we go on to use that in the expression as a simpler approach. So because here we are dealing with two ranges. We have the range of, we have the criteria range and sum range. So the criteria range is category, where the criteria is being picked, and we are looking at scholastic as the first criteria, and then the sum range is amount. They don't have to be quoted. You don't put them in quotes. The ranges are not put in quotes, they are names of ranges. So you put them in the expression. It is quicker practice if there's one parenthesis left, a closing parenthesis. You can ignore it by pressing enter, and the system puts it for you. Press enter and the system puts. And when we see this, it means there is a function problem with the function naming of the function. So commonly we meet errors in spreadsheet and other applications. So in a case like this, usually it is naming, function name, and stray characters or something missing. So we need to be mindful even of the spellings. So could be this one was amounts. As here it is amounts. I also put it as amounts here. In the naming, it is amounts. So I had used amount, which is erroneous. So we add the S and then it gives the results. Then we go on to reproduce and then change the category names. The criteria have to be changed so that they meet what is expected. Spell them exactly the way they're supposed to be spelled, lest you don't get any results. Then, so this is a summation by the categories, or what are the criteria in this case. So the criteria has to appear in double quotes, edibles, true. Then we also have where, then does the needful. So that is it with the applications of the if function. Don't forget to be with us. Again, please subscribe to the channel, and then also attempt the quizzes by tapping the link in the comment section. Thank you very much.